Hello everyone, I'm going to explain the example 4. So this is like figure 2.15 of our reference book. So in this example, it's a very easy example. So we have our input voltage supply of V, and then we have resistor R connected to our inductor L. I'm calling it L. So what we want is the relationship between our input V and our output, which is the voltage across the inductor VL. So let me read it from. So it is saying that derive the relationship between the output, the potential difference across the inductor of VL, and the input V for the circuit shown in figure 2.15. Now, so Kirchhoff's second law says that the voltage that is supplied for this loop is shared among all those components that are consuming it. So Kirchhoff's second law my input, my supply is the voltage V, and then that is being consumed with my resistor VL, the voltage across my resistor, and the voltage across my inductor. So it will be like VL. So for my VI, that is very easy. I know that when I have my R and then I is flowing through it, the voltage across that VR is equal to the current multiplied in the resistance. Now for VL, this is my inductor. Again, we assume that current I is flowing through this inductor, and then the relationship that the I has with the voltage across this inductor is I is equal to 1 over L integration of my voltage over time. Now let's replace them inside this equation and see how it looks like. So we want to have VL on the right side and V on the left side. So we kind of need to replace the VR. We are happy with the VL itself. Now let's replace that from this guy. So that is IR plus VL, so we keep the VL as it is. Now here, the R is a constant, has nothing to do with us. So for the I, we kind of need to replace that I. I'm going to use my second equation here to replace that. And that will give me, so what happens is the R will be multiplied in that. So I will have R over L integration of VL over time plus this one stays the same. And that will give me a nice small relationship between my output VL on the right side and my input V on the left side. So this is my input, that is my output, and some order of its derivative. I'm happy with that. It's not derivative in this case, it's integration. So this is integration of my output. And that's it. So I'm going to explain example 5 in next video.